So yesterday, let's just recap that we had learned about central angles. So you have a circle, you have the center of the circle, and then the inscribed angle has its vertex on that center. What did I just say? Inscribed? I didn't mean to. That's a central angle. Central angles have their vertex on the center. Okay, so that is central. Today we are focusing on inscribed angles, which are different. Here's the difference. They have their vertex on the edge of the circle. Yes, they're so cool. So it's going to look something like this. I'll draw another circle here. So I still have the center, so let's call that point B. So I could have an inscribed angle that maybe looks something like this. So that angle right there would be an inscribed angle. So let's go ahead and write down the definition in words so we have it. Inscribed angles have vertex on the edge of the circle. Okay, so, oh, I'm sorry. Didn't realize I was off the screen. Okay, so totally different. They're both angles in a circle, but one has to have its vertex on the center, one has to have the vertex on the edge. What do you call an angle that doesn't have its vertex on the center or on the edge? Nothing really. It would just be like two chords crossing, so we don't really even talk about those. However, inscribed angles, so let's go back. Remember that the central angle, whatever its arc is, it was exactly the same measure. So if this were 20 degrees, the angle would be 20 degrees, and vice versa. If the angle is 20, the arc is 20. Now that doesn't hold true with inscribed, okay? They're different. So the big deal with inscribed is that they are actually half of their arc. So let's put a big star. The measure of an inscribed angle is 1/2 of its arc. And I have a great way to show you this. So what I want you to do, as best you can, just sketch yourself a circle, okay? Make it look as round as possible. It doesn't have to be perfect, but if it's not pretty decent, draw yourself another one. Okay, now once you have yourself a decent circle, go ahead and draw yourself a diameter wherever you want, but really try and get it right through the center. So, and I'll do mine sideways. You can do it any way you want. So do your best to draw yourself a diameter there. Okay, so now watch this. This is so cool. This arc, let me switch colors here. This arc right here. What's the measure of this arc, that whole orange thingy? What is that?
180.
180, right? Because it's half of a circle. Perfect. So that whole orange thing is 180. Got it. Now, what we're going to do is we're going to draw ourselves an inscribed angle so that it ends at these two endpoints, okay? So what you're going to do, you're going to pick a spot along this bottom arc, wherever you want. It doesn't matter. Just pick any point you want. I'll pick this one right here. Who cares? You pick anywhere along the bottom. And now just draw a straight line to each of those endpoints. Draw a straight line there, and then a straight line over to this one. Now, I want you to take a look at the angle that you just made. This angle right here. Tell me, if you drew this accurately, that thing is going to be a 90-degree angle. Look at your thing. Even if you put your dot somewhere else. Watch, I'll do another one. Do the same thing. Okay, so I've got this big old arc up on top. I'll put my dot somewhere else. I'll put it smack dab in the middle. Watch, this is so cool. So I'm going to connect here. I'm going to connect here. Oh, that thing is a right angle again. No way. What sort of sorcery is this? Hold on. I'll do one more because I think I can fit one more in here. Same thing. I got half a circle. There's my arc. Okay, and now I'll pick it. I'll put it really kind of close over here. Put it like there. So I'd have it that and. No way. This is so weird. Or is it? It's not weird if you understand what we just said. The measure of an inscribed angle is 1/2 of its arc. Look at each one of these inscribed angles that I just drew that ended up being 90 degrees. Look at their arcs. They're all this orange thing, and it's 180 every time. So what's half of 180? It's 90. That's so cool. So that actually makes sense. Anytime I have an inscribed angle whose arc is half the circle, it's going to be a right angle. No way. Obviously, they're not all right angles because every arc isn't 180. But if it happens to be, you can see that no matter where it is, it's going to end up being 90 degrees. Let's try some more that aren't necessarily 90. So oh, that's a terrible circle. Hold on. I can do better. Sometimes if I like just use my finger really quickly, it'll just go away. But I guess I need the eraser today. All right, let's try this again. Well, that came out great. That's pretty good. All right, so I don't know. I'm just going to draw myself an inscribed angle here. And this time it's just there, right? So this right here is an inscribed angle. So how we go ahead and take a look at this, its arc, if I follow the angle, its arc is just this piece right here. Okay, so the measure of the angle is going to be half of whatever that arc is. So if I told you that arc was, I don't know, how about 80 degrees? Whoa, whoa, whoa. 80 degrees. Then you know, okay, well, this inscribed angle, that doesn't look like an 80 at all. That's a little better. Okay, so if that's 80, then my inscribed angle is just half. It's just going to be 40. That's all. That's not so bad, right? So I'll put that there. A little bit trickier just because you have to do half. With central angles, it's easier just because it's exactly the same. And here you need to remember to do half of it. Okay, so the only way that these get harder is by having more complicated diagrams. So let me try and add a couple of parts to this one. All right, let's say we did this. Let's say that this arc right here was, I don't know, 100. Could you find me angle 1 and angle 2? Oh, let's do more. I'm going to add this. What if this arc down here was, let's say that one was 80. Find me angles 3 and 4. And now find me 5 and 6. All right, yeah, try that. Ooh. I will give you a hint on this one. I would actually probably find them in order. I'm going to make that 100 a little darker. Okay, do we have some answers? So I gave you the recommendation to go in order. I would start with angle 1. Does anybody have an answer for angle 1? You can send it to me in the chat. You could unmute yourself. Angle 1, I'm looking for. Anybody? Angle 1. You're going to leave me here like this after all we've been through? No one will answer me? All right, so if you don't know the answer, it's not that you're not willing, it's just that you don't know it. I'll help you. So take a look at angle 1 is down here. He's an inscribed angle because he has his vertex on the edge of the circle. So that means he's going to be half of his arc. So if I follow the sides of angle 1, his arc is this one up here that's marked 100. So angle 1 is going to be half of that. I can ignore everything else in the picture. I don't really care about all the other stuff to find angle 1. He's an inscribed angle, so he's going to be half of his arc. So angle 1, 50 degrees. Now, what's so cool about this diagram is that angle 2 is also an inscribed angle, and it just so happens to have the same exact arc. Right? So if you follow angle 2, both of its sides all the way to the edge of the circle, its arc is also 100. So that means angle 2 has to be half of 100 also. So it has to also be 50. So angles 1 and 2 are equal to each other. They're both 50. Isn't that something? So now when we move on to angle 3, angle 3 is another inscribed angle. Its vertex is on the edge of the circle. So it's got to be half of its arc. So find its arc and then take half. So who can tell me angle 3? 40 is correct. Thank you. Does everybody see that? So angle 3, if I follow its angles all the way to the circle, its arc is 80, so it's going to be half of that. So I get 40 for angle 3. Guess what? Same thing happens for 4, doesn't it? 4 has the same arc as 3 does. They both have this bottom one. So again, you get another pair of angles that just so happen to be the same. So angle 4 is also going to be 40 because it's half of 80. Now, 5 and 6, will definitely confuse you until you realize something about this diagram. Does anybody have an answer, first of all, for 5 or... Well, let's go back. 5 and 6 should be the same, right? Because they're vertical. But they're not central angles like they were yesterday. So there is a way, and you have a way to solve this. And I'll give you a hint. You've known how to solve this for, I don't know, a long time.
Add them up, you get 90. Once you add them all up, they all add up to 180. And then you add those to 180 up, you get.
So I think you're saying what is correct.
Yes.
Don't you have, look inside this circle. Aren't those triangles in there? Look, here's a triangle. Here's another triangle. Don't you know 2 of the angles? So let's just look at this one. I know that angle 1 is 50. I know that angle 3 is 40. So that 50 and 40 is 90. These 3 have to add to be 180 because this is a triangle, right? So that means that angle 6 has to be 90. So if 6 is 90, that means 5 is also 90. So you could have just used the fact that you had triangles here. These aren't special parts of a circle. This isn't an inscribed or a central angle. It just so happens that you had triangles formed in there, so that's how you could solve for both of those. Oh, what fun. I know. Okay, I want to do one more, and then we will talk about circumference and area. Oh my gosh, how is it 10:05 already? The heck? I'll just do this last one really fast. Oy. Where does the time go? It's because I have so much fun with you guys. Class is just over before you know it. So I just want to remind you that if it's a central angle, remember it's going to be equal to the arc. Okay, so here in this picture, that angle right there, so let's call this angle 1, that's just going to be equal to whatever the arc is. If I have an inscribed angle, it's going to look something like this. Angle 2. Okay, so let's try this. If I told you that this arc was, oh, I don't know, 60. Can you find me the measures of angle 1 and 2? This should be quick. Yes, angle 1 is 60. It stays the same because it's a central angle. So that's the same. Angle 2 is inscribed. If it has its vertex on the edge of the circle, it's half. And you can even look. They both have the same arc, but you can tell that angle 2 is smaller than angle 1 for sure. So it makes sense that it's going to be half. So that one's going to be 30. Okay, so that's it about inscribed angles. Now we need to talk about circumference and area. And I know that you have seen these before, so I'm just going to give you the formulas and try a couple of them, and that's it. All right, so circumference, a lot of times kids mix these two up, circumference and area. Circumference. Circumference is literally the same thing as perimeter. It's just for a circle. So it's just the outer edge. So if you were to walk around in a circle, it's how far did you walk, okay? It's not the space on the inside of the shape. So it is distance around the edge of a circle. All right, its formula is C equals 2 pi r. R just stands for radius, that's all. For pi, we're going to be rounding to 3.14. there is a, on a scientific or a graphing calculator, you will find a pi button. So you could use the pi button if you felt like it, or you can just round to 3.14, either way. The units for circumference are just whatever they are, feet, meters, whatever. You don't square it, you don't cube it, you don't do anything weird. It is, because think about it, if you went outside and you walked around the track, assume that the track was a circle. I know it's not a circle, but pretend that it was. If the track was a circle and someone said, oh, you went for a walk, how far did you walk? You're not going to say, oh, I did 1 mile squared, right? You would just say, oh, I walked a mile. Right? The units are just exactly what the units are. You don't square it, you don't cube it, because it's just the distance. When we talk distance, we just use the units as is, okay? So units are simply feet, meters, inches, whatever they are, miles. They are not squared. Okay, so that's literally all circumference is, distance around the edge of a circle. And I'm going to give you area right now too, and then we'll just practice them both kind of together. So area, as you know, is the space inside the circle. So if I were going to, I don't know, I know we have a turf, but imagine that we had like grass inside the track. If someone was mowing the lawn inside the track, they would mow that whole area. So that would be, we would use area to calculate that. Or when they bought the turf, right? They needed to know how many square feet to buy, because that is covering an entire area. So I'm sure the turf, we were probably charged by the square foot or square meter, whatever. So there you have it. So space inside the circle. Here's the formula for area. A equals pi r squared. And I'm going to tell you something. Kids always mix these two formulas up. I can't tell you how many times kids will do circumference and they'll do pi r squared, or vice versa. So here's my best way for you to remember. First of all, it's on your reference sheet. So when in doubt, just look. But you don't always have a reference sheet with you, right? I mean, you always have Google in your pocket now, but let's just assume that you're going to do this. Or maybe you're taking the non-calculator part of your MCAS. I don't know. The formula, you guys are pretty good about knowing that area is squared. So it's units squared, square feet, square meters, square miles, blah, blah, blah. So that's the formula that has a squared in it. The units will help you, okay? So if you know that the units for area are squared, just remember, oh, that's the formula that has the squared. Because look, it has the same parts. It literally is the same parts. It has a 2, a pi, and an r. This one has a 2, a pi, and an r. They're just in different places, and we handle them completely differently because the 2 becomes a squared, right? But it's the same 3 pieces. So I can totally see how kids mix it up. Sure. But take a minute and remember that the units are squared, so the formula is the one with the squared in it. Units are always squared, like the formula. Okay. The only other real common mistake is to use the diameter instead of the radius. Does anybody do the formula for circumference as pi times the diameter? You can, because 2 times the radius is a diameter. So if you are just doing a diameter times pi, it will get you the same thing. I don't usually like to put that on there because now you have yet another formula to look at. I mean, it's totally up to you. You can. All right, let's do a couple and then we'll be done. So if I give you, oh my gosh, these pens. This is a brand new pen and it's already giving me issues. I tell you. That's the only negative of this special notebook is that my pens run out too quickly. All right, so let's say I gave you this circle and I gave you that this was 6. Find the circumference and area. Circumference. Let's spell it right. So all I have to do is give you the radius or the diameter, right? Either one. Because if you have a diameter, you could find a radius. And that's all you need. So if I'm going to do the circumference, it's just 2 pi r. So all I have to do is plug in the radius of 6 and then grab my calculator and do the, let's say that these are meters. So I'm going to do 2 times pi times 6 in this case. So where's my calculator? Here we are. I believe on your homework I have it all to give the answer as a decimal. So sometimes you will see them give the answer and leave pi in it. So they might just multiply the 2 and the 6 and call it 12 pi. That is a valid answer, but if they want you around to the nearest 10th or 100th, you're going to go ahead and do 3.14 for pi. So if I do that, I get 37.68. Meters. Would I square it? No, because it's circumference. Circumference, you just leave it as meters or feet or whatever's. All right, now let's see how it changes with area. Because area should be pi r squared. So I'm not expecting to get the same answer here. So let's see. Pi, my radius is just 6, but this time I need to square it. So before I multiply in the pi, if I just do 6 squared, that's 36 pi. So this right here is what we refer to as an exact answer. Because once you change pi to 3.14, now it's a rounded answer. Automatically, because pi isn't 3.14, right? It's 3.14159, blah, 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 forever. So we are rounding our answer once we chop it off and just call it 3.14. Which is fine, because eventually you have to leaving, I don't know, keeping it as a decimal, it's too big to work with. So I can chop it off. I just don't want to chop it off too much. So if I do 36 times 3.14, I get 113.04. I should actually put squiggles because this is an estimate now. 113.04, and then my units are going to be meters squared. That's it. Does anybody have any questions? I'm going to give you one to try while I make your homework live. Do the same thing for this circle. This time I'll give you a diameter. Let's say the diameter is 10 meters. So find me the circumference and find me the area. Try those two while I make your homework live. Sorry, it keeps flashing. If I'm on a screen that's not the shared screen, it freaks out. Okay. All right, so looking at this, does it still work? Let me go back to my, this back up in the front. Let me just stop and reshare it. And then that should work. Okay, perfect. So for the circumference, 2 pi r. So hopefully you got 2 times pi times, careful now, my radius is not 10, the radius is 5. So an exact answer would be 10 pi, but I'm telling you right now, they're going to ask you to round to the nearest, it's either 10th or 100th. So grab your calculator and do 10 times 3.14, which of course is just 31.4, right? Yes, of course, 31.4. My units are just going to stay meters. I don't do meters squared. I don't do nothing weird. Okay, and then area real quick, pi r squared. Let's see if I can squeeze that in there. Pi r squared. So for area, pi, again, you have to use the radius, not the diameter. So the radius should be 5. So I'm going to do 5 squared. So my exact answer would be 25 pi. And then we're going to round it. Oh, I forgot my squiggles to round it. So we're going to round it to 25 times 3.14 is 78.5. Yeah, so those of you that sent me that, you are correct. 78.5. And don't forget, it's going to be meters squared, because it's an area. Anytime you have area, you are squaring the units. Sorry, I know I'm like squashing it in there. But that's it. So that is all that we have for today. I just made your homework live. So it's on CUDA again. This is homework 29. I am just going to hop over. So feel free to, you go ahead and get started if you need to, but I'm going to share a few for the video, and if anybody needs it. If I could get it to do what I want it to do. There we go. Close this and then share this way. Perfect. Okay, so you'll see a bunch of them where I'm either asking you for the measure of the inscribed angle or the arc. In this case, they give you that the arc is 45. So I'm sorry, the inscribed angle is 45. So I need to find the arc. So in this case, wouldn't I have to double it, right? Because the arc in here is half of its arc. So if the inside angle is 45, that means the arc had to be 90. Right? Does that make sense? So my arc right here has to be twice as big as this angle. So that's got to be a 90. Okay. Same thing. So here I have 57 is on the inside. So in order to find this arc, I'm going to have to double it. So let's see if they give us one. Okay, so here's one where they gave me the arc, and now I need to take half of it to get the inside here. All right, so just be mindful of that. The angle is always half as big as the arc is. All right, and let me just jump back. Yeah, that should be fine. All right, so you have a bunch like this. And don't get alarmed when they start looking more confusing. It doesn't matter. All this other stuff in the picture really doesn't matter. Look at the angle they gave me, 55, and follow it. Follow its side. So here's one side, here's the other side. Its arc is exactly what I'm looking for. So all I have to do is take my inscribed angle and double it, and I get that arc. That's all. So don't get confused by extra lines in the diagram. They don't mean anything. Okay, now I'm asking you for circumference. So make sure that you are using C equals 2 pi r. And they're telling you right here to just go ahead and use 3.14. So this should be pretty straightforward. Just pop it in. Just be careful because it's going to switch from circumference to area at some point. So let's see. There you go. So just be mindful, it's eventually going to start saying area. So when it switches to area, now you know you're using pi r squared. Okay, and that's it. So it should be a relatively short assignment. I know some of you have already started. Does anybody have any questions right now? No? Okay.